Welcome to the Inquisitive Engineer. Have you ever wondered why they put lead in paint, and more particularly in house paint that you would paint the walls inside your house with? Well, if you do a quick search on the internet, it typically says that lead was added to paint as a corrosion inhibitor or to speed up drying. Well, this does not have much application for painting the walls inside your house. Plaster and drywall is not going to rust or oxidize. So if lead is not used as a corrosion inhibitor for house paint, how has this soft, dull gray metal wound up on the walls in older houses? Well, chemistry is an amazing thing. You can take elements and combine them into compounds, and these compounds have properties that are vastly different from the original elements that were used in the creation. And this is where lead in house paint gets its origins. If you go to the hardware store to purchase paint, if you're repainting your house, you'll notice that all the paint cans are of base white, and they add different colored pigments to get the color that you desire. It turns out that that white base historically was a lead compound, and more specifically lead carbonate. Lead carbonate was a white powder, much like this all-purpose flour here, and you could mix it with oil-based materials and make a good base for any color paint that you would like to have. Now, lead paint has been banned in the United States for use since 1978, and many other developed countries have banned it over the last 5 or 6 decades. So what have they replaced the lead carbonate with in the white base in modern day paints? Well, the predominant pigment now is titanium dioxide, and to a lesser degree, zinc oxide is also used. So mankind has known that lead is bad for you for centuries now. So you may wonder why it has only been in recent decades that lead was banned in paint and they switched to titanium dioxide or zinc oxide. Well, a lot of it has to come down to supply chain and cost. Man has used lead for centuries. We've been mining it for centuries, smelting it down, purifying it, and using it. So it is a cheap material. And to make lead carbonate, historically, man, centuries ago, could hammer lead into really thin sheets, coil it up inside an earthen crock pot, add some vinegar, and just set it away for some time. And over time, the acetic acid in the vinegar reacts to the lead molecules on the outside surface area of that lead sheet, creating the white compound. And they could go ahead and scrape that white compound off and use it in paint. Now, this can also easily be scaled up with modern industrialization, which made it a very affordable pigment. White lead also has some properties that really made it the choice for paint, not just because of cost. For one, white lead is easily suspended in an oil-based compound, so when you mix the paint up, it stays mixed for hours, if not days, so it makes application to walls easy. It also has great opacity, where it takes fewer coats of paint to uniformly cover the wall with color. On top of that, it is also a durable surface finish that will last for years and years and years. White lead is also not very dissolvable, more appropriately miscible in water. So when you would wipe your walls down, paint would not be coming off the walls. So as you can see, there is many reasons why white lead was used in paint for so long. And some people argue that, well, businesses are greedy and they did it to save on cost. But I argue that at the same time, consumers are very frugal. If, say, 100 years ago in 1920, a person had a choice between a titanium dioxide based paint and a white lead based paint, and if the white lead based paint was significantly cheaper, they almost certainly would have went with the lead based paint. Lead based paint on your walls is not dangerous to you and people living in a house as long as it's not disturbed. So there's low risk actually painting your walls with lead paint until you maybe decide that you are going to repaint a room and you're going to sand the original paint and scuff it up, and that is going to get lead particles in the air and you're going to be able to breathe them in. They can get in your bloodstream and cause acute lead poisoning. And it's particularly dangerous to children because white lead or lead carbonate actually has a sweet taste to it. So if a child eats a paint chip, it doesn't taste that bad, and it actually may taste good enough to the point where they want to go ahead and eat more. Now, if a child were to ingest a chunk of elemental lead, it's likely not going to cause lead poisoning to them because, say I took a bite out of this lead ingot here, there's a lot of volume, but there's not a whole lot of surface area on the outside, and your digestive tract is not going to break down and extract much of the lead on the outside surface area of that chunk that I bit off, and I will largely pass the chunk of lead that I ate out in the bathroom. Now, if a child eats lead paint, that pigment is ground into an extremely fine powder that has much greater surface area than if I bit a chunk off of that lead ingot. Because there's so much more surface area and it's such a fine powder, your digestive tract can absorb the vast majority of the lead that was in that lead paint. Lead paints can vary on the amount of lead pigment that was in it, but lead can often exceed 50% of the solid content of a lead paint. So even eating a few chips can give you a very high acute dose of lead. So now that we know why they actually used lead in house paint, what about some of those other uses such as corrosion inhibitors and to speed up drying? Well, the application of speeding up drying is that some lead compounds were used in a very small quantity as a catalyst for paints that undergo a chemical reaction, such as clear coat on a modern day vehicle, where you mix two different ingredients together. They have a chemical reaction that turns into a solid. Lead compounds in these cases will speed up the hardening process. I would not call it a drying process. White lead in house paint did not speed up the drying process because this was just an evaporative paint where some solids were suspended in an oil-based liquid, and once it was painted on the walls, the oil-based liquid would evaporate off, leaving just behind the solids. Now, what about rust inhibition? Yes, some lead compounds exhibit better rust inhibition than others. And there is a very famous United States landmark that owes its color to a lead compound used to protect the steel that was used in its construction. When Bethlehem Steel shipped all this steel to the construction site, they protected it with a primer that had a lead-based compound, and this compound was lead oxide. And lead oxide has a orangish red color. And now you may guess what famous structure this is, and it just happens to be the Golden Gate Bridge. The Golden Gate Bridge more than likely was just going to be painted gray like every other bridge of its time, but during construction they really fell in love with that orangish red lead oxide primer, and the color stuck, and now it is famously called International Orange. Thank you for watching. Please like and subscribe. Feel free to leave comments. And as always, stay curious.